Okay, questions anyone? No? Anna, questions? Oh, okay. Right, let's go through the rest. Yes. Write your name as well. Oh, it's there already. Yeah. Now let's go through the rest that we haven't done yet. Charlotte, your worksheet. Okay, let's see. We were in the MCQs, right? I believe I've done 1 to 4 already. Now, okay, let's look at number 5. Carbon monoxide, oxygen, what volume of CO2 is produced? Hannah? Yes, B for boy, make sure you get that right. Remember, these are all gases, so you can use a volume ratio. Hold on, a bit tired, let me use this. Now, number 6. Mass of sodium hydroxide present in volume. You're given volume, 1 dm cube. You're given concentration, 1 mole per dm cube. So, yes, immediately you can find the number of moles, and then from there you convert to mass. Bernice, do you do that? Oh, you didn't. Charlotte? Don't know how to do. Come. There's only one formula that you can use. Volume is 1, concentration is 1, and of course, that tells you you only have 1 mole. Okay, so of course, 1 mole of sodium hydroxide convert to mass, multiplied by your MR. You should get your answer. So number 6 answer is D for dog. I hope you realize you are using all the same formulas over and over again. Charlotte? Okay, look at number 7. Hydrogen sulfide burns in excess of oxygen. I hope you notice that word excess highlighted in your question, which means that hydrogen sulfide is limiting. So 48 dm cube is burned. How much sulfur dioxide is formed? Question? Okay, C for cat. Yeah, the ratio is 1:1 or 2:2 in your equation. So that means 48 dm cube of H2S will give you 48 dm cube of SO2. Okay, Charlotte? Okay, number 8 is the same as number 2, so I won't go through that again. Look at number 9. Magnesium and hydrochloric acid. You're supposed to know the ionic equation. Take one. You should get D for dog. Anybody needs help with ionic equations? Writing ionic equations? Oh, all fine. Okay. Shivendra? Okay. Look at number 10. Excess of zinc. Again, guys, please highlight all these words. Zinc is in excess, so HCl must be limiting. I mean, if you can't compute that, write that down somewhere. HCl is limiting. Now, what's the maximum volume of hydrogen evolved at room temperature and pressure? I think I mentioned this last week. Whatever is limiting will control the amount of products. So in this case, HCl is going to control how much product is formed. And the product, of course, includes H2 gas. Shivendra, did you do this? B, B for boy. Okay, the answer is actually A. Now, if I look at HCl, what are you given? Same thing, you're given volume, you're given concentration. So, mole of HCl equals to Cv. Concentration is 1. Volume, I have reminded you again and again. Make sure it's in dm cube. 100 cm cube is 1 dm cube. So, in this case, it's 1000 cm cube is 1 dm cube. So, in this case, it's 0.1 dm cube. So, that means I only have 0.1 mole of HCl. Okay, and how much H2 are you producing? So, therefore, 0.1 mole of HCl will produce 0.05 mole of H2 because the ratio is 2:1. Okay, HCl to H2 is 2:1 based on the equation. I hope you noticed that. What else? But that's not the answer. You still want to find volume? Come, Charlotte, how to get volume from the number of moles? Mole to volume, you? Yeah, that's all. Alright, so if you use your calculator, you should get 1.2. Yep. Next one, 11. Equation is shown. What numbers? Oh, this one you better know. Hannah? Yes, D for dog. Okay, yeah, you better get it right. This one is very straightforward. Number 12. Ethene and oxygen react based on the equation. Okay, oh, by the way, guys, just to reinforce what I've always been saying, what kind of reaction is that, Dick Wai? Yeah, it's a combustion. Number 12, you see oxygen as a reactant, you see CO2 as a product, and of course in this case water is a product too. It's actually a combustion reaction. Okay, so just get used to it. You need to burn with oxygen on the left. So what's the total volume of gases remaining at the end of the reaction? Charlotte, do you do this? 12. Which one? D for dog. B for boy. Oh, okay, you got it right. Anybody need me to work it through? No? Hannah? Fine, Hannah?
No, I need.
Oh, you need, okay. So I have ethene, you have oxygen, 3, you have 2 CO2 and 2 water. So initially, what are you given? 20 and 70. 20, 70. Of course, no products. 0, 0. Of course, you can leave it blank if you want to. Come, look at this. Who is limiting? Is it ethene or is it oxygen? Which one is limiting? Oxygen?
Okay, it's 70.
Yeah, Anna, which one is limiting? 1:3. Okay, so if ethene is limiting, need 20 for ethene, 60 for oxygen. Do I have 60 for oxygen? Oh, I have more than that. I have 70 for oxygen. So therefore, oxygen is in excess. And conversely, ethene is limiting. That's how you work it out. Can, Hannah? Okay, so anyway. Alright, so we have established that ethene is limiting. Therefore, reminder, whatever is limiting will be fully used up. Fully used up. Or 20 cm cube. Yeah, 20 cm cube will be used up, minus 20. Oxygen in excess, you minus all 60 because the ratio is 1:3. 1:3. How about this? How much will you produce here, Hannah?
40.
Yep, plus 40 because 1:2. 1:2. But look at the water. What state do they add to water over there? It's not a gas. I hope you notice, highlight that. Water is a liquid in this equation. So liquid not counted. Alright, the volume for liquid is really, really small. So reminder, please check your state symbols very carefully. Sometimes they'll give you water as a gas. Sometimes they'll give you as a liquid. So yeah, you really have to see. You really have to. Okay, so then final. 20 minus 20, like I say, ethene is limiting, nothing is left. How much oxygen is left? 70 minus 60, 10. 0 plus 40, 40. 0 plus small, small. So total, 0 plus 10 plus 40, total is 50. Okay, so total volume of gases will be 50. Can, so just, I mean, obviously this is a trick question because you really have to check that, or which are the gases in your reaction. Questions, anyone? Question? No? Now look at the 13 I have HCl. Concentration is given 0.1. How about sodium carbonate? What are you given? You're given volume 25, you're given concentration 0.2. And immediately, guys, once you have concentration and volume, think about this formula. Concentration, volume, immediately think about calculating number of moles for sodium carbonate. Okay, anyway, how much HCl is needed for this reaction? Question? Okay, the answer is A. Because you missed out something. How do I do this? Guys, try to remember this by now. Mole equals to Cv, but mole of what? Sodium carbonate. C is 0.2. Concentration is 0.2. Volume is 25 cm cube. Second reminder of the day. Make sure convert to dm cube for volume. That will give you 0.0054. But they are not asking for that, they are asking for HCl. So how much HCl do you need? 0.010 HCl. Why? Remember, mole ratio is 2:1. So HCl is 2. Sodium carbonate else are we given? HCl, you're given concentration, no? Right, HCl, given concentration. And now you know the number of moles of HCl, so you use like exactly the same formula. Just that now it's for HCl, just now was for sodium carbonate. HCl is 0.01. Concentration is given in your question, 0.1, so the only thing is to find out what is V. Okay, they will give you 0.1 dm cube, and of course, please convert to cm cube. Now you have your answer. Yeah, you just play around with all these formulas. Just that you have to be careful with the mole ratio, you have to be careful with what substances you're referring to. Can questions? Okay, that is for number 13. Now look at 14. 14, you're given 2 grams of calcium. Now, once you see the mass, you think about converting it to moles. Reminder, guys, whenever you have a reaction in your question, you have to use moles. You cannot run away. Okay, once you have a reaction, think about converting everything to moles, because even though the answer may not ask for moles, but in between the intermediate steps you include moles. That's the purpose of moles, no? Moles are used when you have a reaction going on. So anyway, 2 grams of calcium, how many moles is that? Hopefully you remember this by now. Alright, calcium, 2 grams, how to convert to mole? Simply divided by the AR, or in this case it's an element, so I use the word AR rather than MR. Okay, so yeah, you should get your moles. So, what else? It's completely burned in pure oxygen. Guys, can you highlight that word completely? What does that tell you? Completely. It means calcium is limiting. Okay? Calcium is limiting, and conversely, oxygen is in essence. That's the implication. No? When something is completely used up, it means that's the limiting reactants. So anyway, which volume of oxygen is used? Take one. 14. D for dog. Okay, answer should be C. C for cat. Okay, anyway, as I was saying, you should get how many moles? 0.05 moles. AR for calcium is 40, by the way. Okay, one reminder, which I've stressed a few times before, make sure your mass is in grams. Grams is not SI unit, but for this kind of calculation, you need to be in grams. Okay, it's not the SI unit, but you have to be in. It has to be in grams. Mass has to be in grams before you divide by MR AR. Okay, so anyway, what else? How much oxygen do I need? Well, so I have so many moles of calcium. So how many moles of oxygen is needed? What's my mole ratio? Calcium to oxygen. 2:1. Okay, 2:1. So how? I have this number of moles of calcium. How do I get moles of oxygen? 2:1. So I divide by 2. Okay, and I should get 0.025. are more than enough. As I said, oxygen is the essence. But I still need this amount. How to get my volume? Well, you use your good old formula, which I've erased it. From mole to volume. Make sure it's a gas. Times 24 dm cubed, and you should get your answer. Yep, which is 60, oh sorry, 0.6 dm cubed. So don't be careless. You still need to look at the mole ratio, which take one I believe you didn't. You missed out the mole ratio or something. Okay. Hopefully you know what I'm saying. At least remember this from last week. Okay, so yes, that's the formula I've been using all along. Make sure you remember that. So as I said, not many formulas. Alright, last week I think I given you how many? 5 only, right? Yeah, that's all. With this 5, you're supposed to solve every single question. Oh, questions, anyone? No? Okay. 15. Oh, you better be able to answer this. Which ions are in the compound iron sulfate? Yeah, take one. C. Make sure you recognize there's iron 3 plus and SO4 2 minus. Yeah, you should get that. In fact, you must get that. Okay, 16. Okay, iron 3 sulfate again. What values of X and Y? You better get it right because the answer is in 15. Shivendra. Yeah, B for boy, Okay, X is coefficient, the subscript X is 2, subscript Y is 3. 17, glucose. How many grams of glucose are added to 50 cm cube of water to make a solution of concentration 0.4 mole per dm cube? What are you given? Volume 50, concentration 0.4. Come on, by this time you should only think of one thing. Mole equals to concentration times volume. Okay? Hannah?
A.
Yes. A. 17, the answer should be A. Concentration times volume will give you mole. Mole times mR will give you mass. Anybody need to write out? Question? Okay? Okay, yep, great. Alright, questions for anyone? No? No? Okay. Denise? No? Okay, so anyway, just a very quick one. Okay, so this is the formula 2. Alright, make sure you remember formula 1. Mole equals to mass over mR. Formula 3. It's up to you, but for me, mole equals to CV. Make sure your C concentration is mole per dm cube. Formula 4, mass equals to CV as well. But of course, in this case, your C is in gram per dm cube. Alright. Okay, yeah, 4 basic formulas, even though I given you one more last week. Yeah, that's all. Just based on this, you can work out everything. Alright? Okay. Guys, there's something that I just want to quickly run through. Do you have any recollection of dot cross diagram? Yeah, take one. Yes, no. Yes, the rest, yes, yes, Okay, come, just draw me. Okay, yeah, just quickly draw this up. Dot cross diagram for CO2. Ask yourself first, is it a covalent or ionic compound? Bernice, you try as well. Does it have any metal inside? If there isn't, then, well, it ought to be a covalent compound. And that means it involves covalent bonding. Or anybody needs periodic table. This is not a test, so if you have any questions, make sure you ask.